Hi everybody, this is our first lecture of the semester. As I mentioned in the video going over the course and the syllabus, that we are actually starting with Chapter 2. Why is that? Because Chapter 1, there's a lot of sort of little small details and terms. I didn't want to start the course by hitting you with all of those types of things. I wanted to start with Chapter 2 because it's a little bit more hands-on and a bit more straightforward, and we're actually looking at some data, and I think those things are a lot more common sense than the stuff in Chapter 1. So let's start off with an easy thing and sort of slide well into the course here. So here we're going to be looking at frequency distribution. So that might sound a little bit weird. Let's just think about what that means. And so in psychology, for example, I'm a psychologist, when we do research, we measure variables, things that people vary on, variables, people vary on it. So, for example, one of the things that I've studied and published is studies on narcissism. So I can measure narcissism in different ways. Narcissism, by the way, are people that are very self-absorbed. They think highly of themselves, but that self-esteem, if you will, that they have, the high self-esteem, is very vulnerable and fragile. So if somebody says anything against them or gives them some sort of even very little slight, they get very angry and vicious towards those people and attack them. So they're very arrogant. They need a lot of praise from other people, and when they don't get that praise, they get very angry. This might sound familiar if you think about somebody very famous in power at the moment. So people vary on narcissism. Some people are highly narcissistic and some people are low on narcissism. And so that's a variable. People vary on it, and we can measure it in different ways. We could measure it with a questionnaire. We can ask people questions, or probably better is the way I've done it is we can have trained observers watch somebody in several different situations and rate their behavior and rate that on narcissism. We could also have friends, for example, we can ask friends about that person's behavior and rate them on narcissism from high to low. So there's various ways that we can collect those data. But the key point is that that's a variable, narcissism. People differ on it. People vary on it. Some people are high, some people are low. And in this case, we can put numbers on it. So let's say 100 is a perfect narcissist or extremely narcissistic, and 1 is the lowest narcissist that could exist. And so we have a bunch of scores there. So we have people in our sample of people we've measured. They could have scores 1 through 100. And so what a frequency distribution is we look at each possible score that people have given us. So, and then we count how many people have that score. So let's say there's a score of 90 on narcissism. How many people got that score? Let's say 3. Then 89, let's say that 4 people got that. So that's what a frequency distribution is. We're simply counting the number of people in our sample that has different scores on the variable. This will become more clear as we do some examples. And we're going to be doing stuff that's very hands-on, and I'm going to start showing you SPSS. And so there will actually be a lab that is due on this topic in SPSS that will be on Canvas. So we'll be using SPSS to create some frequency distributions. And if you have not watched the video for the overview of the course and the syllabus, I recommend that you do that now, because lots of points are made there that you need to know for the course. And one of those points is that you do not need to have the software of SPSS to do these labs. And so I will be running the stuff for you. Just want to see if I can get this thing off the screen. It's just going to be on the screen. So this little thing on the left, we'll just have to deal with it. It's going to be there. And so what we're going to be doing is we're going to be running some of these frequency distributions. And these Frequency distributions are what we call part of descriptive statistics. So what are descriptive statistics? So descriptive statistics just describes your sample's data. So just real quickly, if you don't know what the word sample means, it means that, for example, in psychology, we're curious about people, but of course we can't measure and do research on everybody in the world. That would be impossible. We can't even measure everybody at Chafee. That would be also impossible. And so we take a smaller sample of people, a small group of people that we actually use for our research to collect data on. And that sample then is, we need to describe what that sample's data is like. So if I'm doing narcissism research and I have a sample, I should probably describe to the readers of my research what my sample looks like in terms of narcissism. Are they high or low or in the middle in terms of their average level of narcissism? I might want to also describe if there's a certain percentage that are highly narcissistic. Or I might want to describe the highest score on narcissism. So there's different things, different ways we can describe our sample in terms of the variable. So that's what descriptive statistics are. Descriptive statistics just describe what our sample looks like on a variable. The other type of statistics that you're probably thinking about is what we call inferential. So in research, we take the data from our sample and then we make inferences, conclusions about the total population. So if I'm doing a study on narcissism, I have a sample of 100 people. I need to make some sort of general conclusions about people in general beyond my sample. So those are called inferential statistics. So we will mainly deal with inferential statistics in this course. However, we're going to start with the descriptive statistics because they're a little bit more simple to do. And so again, descriptive just describes our sample's data, and I'm going to go through this with you with some examples about how we can describe data. So we're not testing any hypotheses. So testing hypotheses has to do with, can we make a conclusion about people in general from our sample? That's inferential. So we're not doing that, we're just describing data. And again, the most basic form of this is frequency. So how many people have different scores on your variable? And the nice thing about frequency distribution is that we can do it as a table or we can do it as a graph, a histogram. And I will go over both of these with you. And so again, you do not need to have SPSS software for this course. I will describe in the lab video about what you will be doing. It's also described in the overview of the course and syllabus video. And so I've already opened these data. So here's a data set. And what this is it's called sleep. It's just from a previous year's psych stats course in another college. And it's just asking people from a survey how much sleep on average during certain weeks did they get. So how much sleep on average did they get the first week of the semester? How much sleep did they get on average during the midterm, right before break? Typically there would be a lot of exams at this time at this college. How much sleep did they get during spring break? And how much sleep did they get the week after spring break? So there's 4 variables here. Each of these are variables. People will differ on these things. So there's 4 variables. And just I want to review a little bit about SPSS. So there's a data view and variable view. So right now I'm in a data view. If you look down here on the left, data view. So these are the data actually from our folks, from our people. And so each column is a variable. So you see it says first week here, so that's sleep during the first week of the semester. The second column is another variable. It's the sleep during the midterm week right before spring break when all the exams are happening at that college. Then the third column is another variable. So each column is a variable. The amount of sleep on average during spring break week. And then the fourth column is the last variable, which is the average amount of sleep during the week after spring break. So each column is a variable. And each row is a person. So this is a person. Number 1 is one person. And this shows how much sleep they got first week, midterm, spring break, and the week after spring break. So each row is a person. And if they have a score here, they have a measurement on the variable. So this person, number 5, they got an average of 5 hours of sleep a night, first week of the semester. Midterm, they got an average of 5 hours of sleep per night. Spring break, an average of 9 hours of sleep. And the week after spring break, 8 hours. And so each row is a person and their scores on the 4 different variables in this case. So that's data view. That's the data. That's all the numbers, all the measurements of your variables for everybody in your sample. And these are real people, by the way. So these are real students that answered this. And you can see that the sample size looks like it's 40. So we have 40 rows, so there's 40 people in our sample. And then there's variable view. So if you go down here to the lower left, variable view, and this is just your variable list. So you can drag things in SPSS, so you can make it bigger or smaller if you want to. And each of these rows is just describing each of the 4 variables. So the name that we gave to the first week in terms of the amount of sleep was just first week, without double E for the week. And it just tells us it's a number. So when we say numeric, we're meaning that the number means something in terms of numbers. We'll talk about that in the next lecture. There's a label here. The label will just mean that when we do our analyses, it will actually print out this label. So if we do analysis with the first week variable, it will print out a label that says sleep during the first week of the semester. And so I won't go over the other things, but basically the variable view is just listing your variables. We'll talk about this a little bit more when we get into more complex statistics, but I just wanted to sort of highlight this as a way of sort of naming your variables and then giving a label when you run your statistics. But maybe a data view is the best thing to look at because it looks like, okay, yeah, we have a bunch of people in our sample and we have numbers for each of the 4 variables for everybody in our sample in this case. And so let's go ahead and run a frequency distribution. And so we're going to do it with the variable of first week. So how much on average did they get, how much sleep did they get on average during the first week of classes during the semester? So how much sleep on average per night? So let's just look at it first and we'll describe it. So remember, it's descriptive statistics. So to do this, and I'll do this a little bit more in lab, but this will be useful to have here. So a lot of what we'll do is under analyze. So analyze, descriptive statistics. So all those things we're going to use to describe samples are kind of under here. Descriptive statistics, and look, this says frequencies. So pretty easy. Analyze, descriptive statistics, frequencies. And so actually I already have it there. I'll just make it as it was. So what you do is you can click it over. You can click it over using this arrow, or you can just double click it. That's our variable. That's the sleep during the first week of the semester. And all we have to do in this case is press OK. So here is a frequency distribution as a table. And what I'm going to do is I'm going to snip this so I can write on it. So here's our frequency table. We could say frequency distribution table if you want to be really accurate here. And so the first part is pretty easy. N stands for sample size. And remember I said there was 40 people, there's 40 rows in the data. So our sample size is 40. So N is a symbol for sample size. This little n is a symbol of sample size. What's the difference between valid and missing? It just means that 40 people had scores. And in this case, there was 0 people who didn't have a score for that variable. So it's a little bit of a nitpicky thing, but basically if it says missing, it means they had, that's the number of people that don't have scores for that variable. Okay, then here's the big thing. So remember I said that there would be a label for it because we said to label it. Sleep during the first week of the semester, it's handy to have, we know what's there. And then what's over here is these are the different scores people had for sleep during the first week of the semester. So this is the average number of hours per night. So we have 4 hours, 5 hours, 6 hours, 7, 8, 9, 10, 11. So those are different answers that our sample gave to this question. And you note that it doesn't print out all of the possible answers. It doesn't have 0, 1, 2, or 3. It doesn't have 12 through 24. So it doesn't give you all the possible answers. It just gives you the answers that people actually gave. And so maybe one of the first things that we could actually do here is to describe this sample. We could say that this sample had a range of average hours of sleep per night during the first week of semester from 4 to 11. So that's one way to describe it. We could describe the range of scores. So the lowest score was 4, and the highest score was 11. So the person who got the least amount of sleep got 4. The person who got the most amount of sleep was 11. So we could just start describing that. That could be one of the things that we could describe right away in terms of our sample. What was the range of scores? And then we have different columns here. We have frequencies. This is simply the number of people who said each of these scores. So here's 2. 2 people said they got an average of 4 hours of sleep a night. 4 people said they got an average of 5 hours of sleep per night. You can keep on going down. I won't do every one. 9 people, so frequency is the number of people. 9 people said they got 7 hours of sleep on average per night during that first week of the semester. 6 people said they got an average of 9. And 1 person said they got an average of 11. So the frequency, again, is the number of people who said those different answers on that variable of first week. How much sleep on average did you get per night? So if some of this is easy, you can fast forward, by the way. I think you can go twice the speed on these videos if you want to. So if you find things being really easy and straightforward, you can go faster. I'm going slow just so people can follow everything. Then we have a column here that says percent and valid percent. So these are a little bit confusing. What I'll tell you is, in this case, they're equal because remember, we didn't have any missing numbers. If you just want to look at one, just go ahead and look at valid percent. What valid percent means is that we look at the percent of people based on the number of people who actually gave us an answer to that question. So if somebody didn't answer that question, we ignore it in our percentage. That's the only difference. Don't worry so much if you're getting that one or not. It's not a big deal. So my advice is just look at the valid percentage. And what this just does is it converts the number of people to a percent. So what percent of our sample got 4 hours of sleep per night during the first week of the semester? Well, we take 2, there was 2 people, divided by 40 total in our sample, that comes out to be 5%. And we can do it for everything. So here we have 9 people. So 9 people divided by 40 total people in our sample. 9 divided by 40 is 22.5%. So the percent is just converting the number of people to a percentage of the population. I shouldn't say the population, our sample. So 6 people said they got 8 hours on average. 6 divided by 40 total people in our sample. 15% of our sample said they got 8 hours of sleep on average. So the valid percentage is just what percent of our sample had that answer. And then the final thing is cumulative percentage. What is cumulative percentage? It just adds the percents downward. So here, 5 plus 10 is 15. 15 plus 22.5 is 37.5. 37.5 plus 22.5 is 60. So it's giving us the percent of population or percent of our sample that gave that answer and below. So for example, if we look at 7 hours of sleep on average, it says the cumulative percentage is 60. So what that means is that 60% of our sample got 7 hours or fewer on average in terms of sleep for the first week of the class. Here at 9, I can see at 9 hours of sleep, 9 hours and below, 90% of people got 9 hours or below. So it's just one way that we can actually think about describing the sample. So if you're not quite getting this, we're going to have more examples, so don't worry. So that's what the frequency distribution gives us. So let's actually describe the sample. So we already described the range. And I think I'm going to erase some of this because it's gotten a little bit messy as I've showed what's here. So let's just erase it. There we go. Okay, now we have a clean slate. So we already started a description by just talking about the range. So our sample got between 4 hours and 11 hours of sleep on average per night during the first week of the semester. So that range just tells us the lowest and the highest person on that variable. So part of this descriptive statistics is that there's no set rule. You have to kind of look at the data and see what stands out. So I'm kind of looking here, and it looks to me like this kind of stands out to me. So it looks like that's 45%. So 45%. I'm writing with a keypad here on my laptop, so it takes a little bit longer. So 45% of our sample got between 6 and 7 hours of sleep. So that kind of stands out to me too, is that there's, almost half of our people got 6 to 7 hours of sleep on average. So that might be one thing I described too. I'm just going to erase it just to make it easier. I'm looking here, see if anything else stands out to me. Maybe I want to look at 8 hours. We often think that 8 hours is the magical number, right? That we want 8 hours of sleep a night. So we might want to say, well, how much of our sample got 8 hours or more of sleep? So we actually have to reverse this. So 8 hours is right here. So what we have to do is we have to draw a line here. And what we want to do is we'll take that 100 minus 60. Because we know that 60% of people got 7 hours or less. 7 hours or less was 60%. So if we take 100 minus 60, it means that 40% of our sample got 8 hours or more. Maybe not fantastic. Kind of maybe low on sleep, perhaps. If you're not sure about that, you can always add these up too, because this is for 8, 9, 10, and 11 hours. If you add this, that's 30. And then we have another 10 here, so that's 40%. So 40% of our sample got 8 or more hours of sleep. And let me erase these things here. I want to see if anything else stands out to me. I think that's probably it. I think that's a good description of our sample. So what does our sample look like in terms of the average time of sleep, hours of sleep per night during the first week of the semester? Well, they range from 4 hours to 11 hours. 45% of our sample got between 6 and 7 hours, and only 40% of our sample got 8 hours or more of sleep per night. So those are ways that we can describe our sample. I think that's a pretty fair description of this sample in terms of how much sleep they got during that first week. So again, these descriptive statistics, there's no like rules of what to do, but it might be good to start with a range and then look what stands out. To me, what stood out was there was two big numbers here. So 45% was between 6 and 7. And then I thought, well, for this variable of sleep, 8 hours is kind of that magic number that we think about. So I thought, well, let's just see how many people got 8 hours or more. And so that was 40%. So this is a way of describing the data. And so part of this is just kind of looking at the data and seeing what stands out to you. Okay, so I'm going to get rid of that. So that's a table again, a frequency table. I believe we have another one that we're going to run through here. Actually, I have a little bit more here. So a few people got 5 hours or less. So 15% got 5 hours or less, etc. So let's go to the midterm. So when everybody's having their exams. And so let's run that frequency. And so when you run this, the old analysis will come up. So you see that the old analysis is there. You can either reset it, or you can just click over the variable. I just double click it. There's also an arrow. So you can click that arrow, get it over there. So I'm going to click over the midterm. So on average per night, how much sleep do they get during midterm when they're having all those midterm exams? And I'm going to snip this so I can draw on it. And you can see that it tells you what it's done. So it says frequencies up there. So it's run the frequencies. And just like our previous variable of first week, sleep during the first week, our sample size n is 40. There's 40 people that gave an answer to this question. And so, again, this is a list of the different answers people gave. So we have a range right away. So this range for this variable for this sample is 3 to 10. So right away we can see that at least it looks like people are getting less sleep during the midterm versus the first week of the semester. So our range is lower. Our range before was 4 to 11, so our range is lower. The least amount of sleep was 3 hours per night, and the most amount of sleep was 10 hours per night. And I'm going to erase that just so we have a clean slate. So go ahead and look at this and see how you would describe the data. Pause the video and try it. It's useful to try these things. So let's pretend that we're in class together, and I'm going to give you a few minutes to describe these data. So pause the video, and then I'll go over it after you unpause it. Okay, I'm gonna look here and see what stands out to me. So remember, frequency is the number of people who said the different scores. We'll just ignore the percent. We'll look at the valid percent. So that's the percent of people in our sample who gave that score. And cumulative percent just adds up the percent of people from the lowest score to the highest score. So that's why we have 100 on the bottom. So I'm just going to look at this. So again, part of this is kind of art to sort of how do we describe this. For me, what really stands out is this. There's a lot of people here. There's a lot of people from 5 to 7. That's what stands out to me. There's big numbers here. So if we add these up, We have 22.5 plus 22.5, so that's 45%. So 45%, and that's 52, 72.5%. Should probably write it over here. 72.5% of our sample, that's quite a few people. 72.5% of our sample got between 5 to 7 hours of sleep per night. So that's a pretty large majority of our sample getting just 5 to 7 hours. So not only is the range lower, but we're also seeing that most of our samples not getting enough sleep, 5 to 7 hours. I'm going to erase this just because I want this to be kind of clean. I'll erase these two because we've already talked about these things. Does anything else stand out to me? I'm kind of just doing this live. I'm going to answer that question of that 8-hour mark again. So 8-hour is the thing that we think people should get. And so we're going to look at 7. So 7 is, the cumulative percentage is how many people got below 8 hours. So if we take 100 minus 87.5, that's 12.5, correct? Sorry about that. I'm writing on this little pad. It's not really easy to do. So 100 minus 87.5. So only 12.5% of our sample got 8 hours or more. And if you're not sure about that, you can always just add these up. So we have 5 here, 2.5 plus 2.5, 5 plus 7, that's 12, plus 0.5, so 12.5%. So we can get it by adding that also. So only 12.5% of our sample, very few people, got 8 hours or more. And I'm going to just erase this. I want to make sure that, sorry about that. There's some really funky things that happen here if you're not careful. Oops, the eraser's not on yet. I don't want to, I'll erase, no, I don't want to erase all the ink. There we go. Anything else stand out to me? You may have mentioned some other things, but I think that kind of describes the sample. Because basically what's happening here is people aren't getting enough sleep, right? But we want to be more detailed, right? In stats, we can't just sort of say they didn't get a lot of sleep. So well, what do you mean by that? Well, we mean that the range was 3 to 10. Most of our sample, 72.5% of them, got only 5 to 7 hours of sleep. And if we look at that magic number of 8 hours or more, very few people in our sample got 8 hours or more, 12.5%. So we just described our sample in terms of sleep there. They got less sleep during that time, but in statistics, we have these very specific numbers that we want to give. So hopefully that's pretty straightforward using the tables. Let's look at looking at charts. So sometimes tables are okay, especially when we have a small range of values. So number of hours of sleep, there's only certain numbers that people can have, right? It can't be a very long list. But let's say that we have, like the narcissism example I gave earlier, 1 through 100. We could have possibly 1 through 100 in a table. That's a lot to look at. We can't really process that. So if we have more people, more possible answers that people could have in terms of their data for a variable, sometimes charts are better. So we call these things histograms. Histograms are bar charts. And so let's go ahead and do the same variables. And so I'm actually kind of looking ahead at the next slide. Sorry about that. So we do the same thing, except we're going to just add a little bit. So analyze descriptive statistics frequencies. I'm going to click this over. Let's go ahead and do the first week again first. So we're going to do the same thing, but we want to do a chart in this case. We're going to do a graph. And so here we just click on bar charts. Bar chart is a histogram. Actually, I'll click on histogram. Sorry about that. Histogram. That should be the same, but let's just do histograms. So click histogram, press continue, press OK. And what it does is it gives us the same thing as before. So this is our table. We looked at this table before, but what it adds is it adds this chart here, this histogram. And what I'm going to do is I'm going to snip that. And actually it says histogram. I'll make it bigger so everybody can see it well, hopefully. And I'm going to write on it. So you see here, there's a label. So it tells us right away this graph is for average hours of sleep during the first week of the semester. So on the horizontal axis is the possible variable data that we have. So this is how many hours of sleep. I have a laptop, it always does that, sometimes goes down if I lean on it in a certain way. It's annoying, but we'll put up with it. So we can see here, remember it was between 4 and 11 hours for our sample, that range. So 4 hours of sleep to 11 hours. So these are the number of hours of sleep on the horizontal axis. On the vertical axis is the frequency. So this is the number of people. So here, 2 people got 4 hours of sleep. You can go back to the table if you want, and you can see that that's true. In terms of 5 hours of sleep, 4 people got it. So frequency, again, is just a number of people who said these different answers. So how many people got 4 hours? 2. How many people got 5? 4. How many people got 6? It looks like it's 9. So the bigger the bar, more people are there. And so let's look at this histogram. How would you describe it? Well, we could do some of the same things. It's between 4 and 11. That's our range. Looking at this, and it's a small sample, so it kind of looks a little bit funky, but you know, some of the same things stand out. Just want to make sure it's drawing. This kind of stands out. Here's the big ones, right? These are the biggest bars. So it looks like, you know, quite a few people in our sample got between 6 and 7 hours. This is 7. 7 hours of sleep on average. There might even look like there's a bulk of data here that most people in our sample got between 6 and 9 hours. So we're just looking at the bulk of the data here. So that's one of the things that we want to do is, I'm going to erase all of it actually. Let's erase all of it. Is with the histogram, we can kind of look and say, oh, here's where most of the data are. Is there another way you can describe this? Some of you may be saying things like it might look like a normal curve, a bell curve. A normal curve is one that there's more scores in the middle and fewer scores on the end. It's kind of like a bell curve, but it's not perfect. It's kind of like that. So it's a little bit like a bell curve. So you might want to start thinking about the shape of it too. You kind of look at this, it looks like there's probably, even though there's fewer on the ends, it looks like there's more people on the end getting less sleep versus more sleep. So if we look at those sort of 2 last little bars, it looks like there's more people getting less sleep and there's fewer people getting more sleep. So we might want to kind of mention that. This is actually called skew. So if we actually drew this, this would be a little bit up higher, and this thing would dip down a little bit more quickly and tail off. And so we would actually call that a skew because it looks like a space skew, S-K-E-W, because it looks like there's more people on this tail and than there's on this tail. More people getting less sleep versus more sleep. So we're trying to look at shapes like that with the histogram. And let's look at the midterm. And so again, it's analyze, descriptive, frequencies. I'm gonna click that thing over and I'm gonna click over the midterm. If I do it that way, I still have the command here under charts for histogram. So I don't have to do anything else. If you press reset, you're gonna have to redo all these little buttons over here. So when you can, I would recommend clicking over the variable. It will save your work a bit. Again, you don't need to use SPSS. This is just for maybe your future career. If you can do this type of stuff, you can make a lot more money in your careers. So again, this is for average sleep per night during the midterms when people are taking exams. So the frequency table comes first. It's the same thing. It still gives us that, but it gives us this chart. So look at this chart. Let me sketch this. That's stupid. Sorry about that. It takes a little bit of time to get this thing. If anybody knows how to put it in my taskbar, I've been pretty unsuccessful in doing that. And so let's snip it. So the histogram are bars. And what is a histogram officially? A histogram is a bar graph, but the lines don't touch. You can see the lines, the bars don't touch here. So right away, we can see it's different from what we had before. So remember what we had before kind of was, there was a slight skew, so there was more people getting less sleep, and we kind of had a peak like this for the first week. And it kind of went down a little bit like this, and then it kind of tailed off like that. So it kind of looked normal-ish, but there was a little bit of a tail here because fewer people were getting more sleep. This looks totally different, right? This doesn't look anywhere near like a normal curve. Right away, what probably stands out to you is this. It dives down fast like that. So if we were to draw this, it would kind of look like this. So there were fewer people here during the first week getting more hours of sleep, but here it's really, really obvious. There's a lot less people getting fewer hours of sleep. I'm sorry, a lot more people getting a lot less, I'm sorry about that, a lot fewer people getting more hours of sleep versus less hours. So this tail just goes down. When we get to the higher number of hours of sleep per night, people just disappear. There's not many people here. So it's already looking different. And so there was a slight skew for the first week, but now we have a really big skew. So there's a really big skew here. And the skew is that there's fewer people getting more hours of sleep. So it just dives down here. And actually, we can actually call this, it's called a positive skew. So positive doesn't mean anything about whether it's a good thing or a bad thing. All it simply says is, where is the tail? The tail is where there's fewer people. So this little thing we call a tail. So the tail is over here. The tail is on the higher end of the numbers. So that's what we call positive. So if the tail's over here on the higher end of the numbers, it's called positive skew. If the tail was over here, if there was fewer people getting less hours of sleep, then it would be called negative. And not because whether it's a good or bad thing, it's just because it's negative because we're on the smaller end of the variable, fewer hours of sleep. But in this case, it's a positive skew. So this doesn't even look normal to me. There's a pretty strong skew, and I think it actually even probably looks better without drawing it. Let's erase this. We can just look at it right away, and it is for sure dipping down here. So we already have a description there, is that it doesn't really look normal, and it looks skewed in the sense that less people are getting more hours of sleep, a positive skew. What else stands out? Well, we can look at the bulk of the data, where most people are. Where are most people here? Well, that's the highest bars. Where's the highest bars? Right here, between 5 and 7. So that's similar to what we got from our table, but we're just looking at the graph here to get this. So there's probably basically two things we could say here. We could say that, for one, we could say what the range is. So we can say between 3 and 10 if we want to. But probably this is saying that most of our people in our sample got between 5 and 7 hours, so not a lot of sleep. And that there's a skew here in that not many people are getting above 8 hours or more of sleep. So that's probably a pretty good description, as most people are between 5 and 7 hours of sleep. And there's a positive skew. By saying a positive skew, what we're telling people is not many people are getting a lot of hours of sleep. So hopefully that's relatively straightforward. So you can see that the bar graph actually is probably a little bit easier to interpret because it's a very visual thing. Okay, let's continue with the lecture. So again, I think both of those, the table and the describing of the graph, describes the data well. So first week, people are getting a little bit more. There's a slight skew. There's a little bit fewer people getting less hours, but it's not much. There's still quite a few people, 40%, getting 8 hours or more. The midterm week with all those exams, our sample's getting very little sleep. Okay, let's look at another type of data. So we were just looking at where what we call interval level. Actually, it's ratio. We'll talk about this in the next lecture. But basically, those numbers mean something, right? 1 hour, 2 hours, 3 hours, 4 hours. So theoretically, on that variable, we could have a range between 0 and 24, right? So that's why it's ratio. Ratio, we have a true 0. It's possible for somebody to get no hours of sleep. So 0 is a possibility. And the differences between our numbers are equal. So the difference between 1 and 2 hours is an hour. The difference between 10 and 11 hours is 1 hour. So it's like a step. We just add an hour to the steps. So it's what we call interval level data. Don't worry if you're not quite catching that. We'll review that in the next lecture. There's another type of data that's called nominal data, which are categories. So let's just think here, it has major. So major is a variable. People differ in terms of what major they are in college. But can we say that people are more or less on a major? Like we can say people have more or less sleep. We can definitely say that people have more or less sleep, right? If you get 20 hours of sleep, you got more than somebody who got 18 hours of sleep. So we can say that there's more or less in sleep. Can we say that there's more or less of a major? We cannot. They're just different things. Psychology is not more of a major than sociology, and vice versa. They're just different majors. So they're categories. So we can have data that are nominal, that are categories, and a lot of times we will give these types of data numbers. Sometimes we just keep words, but sometimes we have numbers. In this case, we have the words there. But you can put numbers if you want to. So you can have 1 be psychology, 2 be sociology, 3 be physics, 4 be math, 5 be business, etc. But those numbers are not numbers that you can add or subtract because there's not more or less of them. It's just that those numbers mean a different category. So with nominal data, these categorical data, we can't say there's more or less, and we can't do addition, subtraction, multiplication. We can't do that type of stuff. It's because they're just categories. So let me open up another set of data, and let's look at some nominal variables. Sorry about that. It opens up something when you do this. So here's another set of data. This is actually another survey that was done on some previous courses, stat courses. These are real people with their real answers. And we're going to be looking for people's majors. So analyze descriptive statistics frequencies. So I'm going to look for major. And right here it is. So you can see here, what is your major? I'm going to click that over, and I'm just going to do a table. You can see here that there's words. So you can see here, actually here it's a little bit longer. I think I'm going to snip this so I can make it just a little bit bigger so you can read it. And I can draw also. So here we go. So you see here it says, what is your major? And by the way, 39 people. So we have a sample size of 39. How do I know that? Right down here, it says total. And so 39 people told us what their major was. So here it's the same thing. So this is what people say. So some people said art and chemistry, biochemistry. We have to kind of watch out for things like this with words, because if you spell it different, it comes out as a different thing. So that is something that we want to be careful about. So we have cognitive science, computer science, dance, economics. So these are the different things that people said. Then the frequency, again, is the number of people who said the different things. So in terms of biology, we had 2 people who said they were biology majors. And as usual, let's just use the valid percent. So if we take 2 biology majors, divide by our sample size of 39, 5.1% of our sample were biology majors. And then there's a cumulative percent here. But what I'll say is for nominal data, this is not very useful because there's no order here. Remember with sleep, we went from, for example, 4 to 11. And so we went from lower to higher. With something like this, with a nominal variable where there's not more or less of a major, this cumulative percent is not very useful for us. So I would say just ignore that when you have nominal categorical data. So I am just going to look here for frequencies because there's just pretty easy to look at here. I'm just going to look here and boy, something really stands out, right? Is that we had 16 psychology majors in this class. And 41% of our sample actually were psychology majors. Looking at this, does any other major has anything above 2? It doesn't look like. So there's no other major that has more than 2 people. So if I were to describe this sample in terms of their major in college, I would say that the most frequent is psychology. Oops, I'm not sure why it's not writing here. The most frequent is psychology. Most frequent is psychology, so 16 people were psychology majors, and that was 41% of our sample. And it might be pretty easy also just to say no other major had more than 2 people. No other major had more than 2 people. So everything else was 1 or 2 people. So that describes our sample pretty well, right? 41% of this sample is psychology majors, and for all the other majors, there's not many people. There's 1 or 2 of all the other majors that were mentioned. So that's all we have to say about the categorical variable, the nominal variable of major. We just look here and see what stands out, and this really stands out. Psychology is the most popular major in this course. Makes sense, it's a psychology course. This is from another college. You're in a social science course. Let's try to run a graph for those same data. So remember, analyze, descriptive statistics, frequencies. We go over here to chart, we tell it to do a histogram, we say continue, and we press OK. Where's our chart? Where is our chart? You can't do a chart. Why can't you do a chart? Because you don't have more or less. And I'm just going to snip something here so I can draw. And so I'm just going to snip the empty space here. So remember with our hours of sleep, oops, we could have a chart, and I'm sorry, drawing it as a line here. Let's just say it's a normal thing. And let's say that there's 4 hours of sleep here, there's 11 hours of sleep here, and the average was somewhere around 8, let's say. So there's 4, 5, 6, 7, 8, 9, 10, 11. So we have more or less, as we go on the horizontal axis, we increase the number of hours, correct? So it makes sense that we can do a chart with the number of hours because we can see right here what's more or less. For our sample, are they higher or lower on this variable? For major, we can't do that because we don't have more or less major. We can't say there's higher and lower, so when we try to run it, SPSS won't run it. Doesn't make any sense. There's actually a little warning here. It says I can't do the chart because we told the computer actually that well, there's words there. It already knows, so it knows words are not numbers, and so if it has words, it says there's not more or less of this thing. I'm not going to do it. Okay, let's continue, and I think we're going to roll pretty fast now because we're not going to do much more SPSS, I think, for this lecture. This slide, you don't really need to know. This is fine. You can just leave that stuff. This thing too. Basically, it's just saying, like, for nominal variables, you can actually graph it if you want to. So you could graph major. So this could be psychology. This could be biology. This could be physics. You could graph it, but in your graph, it doesn't mean that it's more or less. It's just showing how many people said the different answers. So you could do it. The machine won't do it. SPSS will refuse to do it. You could do it, but you have to label it in a way that says these things are not more or less. These are just different types of majors. In this case, it's different personality types. So whatever this personality type thing is, it's not that there's one thing that's more or less, that A is less than C. This says there's different types of people. So you could do a bar graph. It's not a histogram, it's a bar graph. But when you do that graph, everybody would know that you can interpret it as more or less. You could see what bar's higher, there's more people who are C, but it doesn't mean that your sample is high on this variable. It just means that more people are the C category of this variable. Okay, let's talk a little bit about the shapes of the distribution. We've actually already done this a little bit. So we talked about a normal distribution. So a normal distribution is one where you probably are very familiar with this. It's sometimes called a bell curve. There's more people in the middle. So there's more people in the middle and there's fewer people on the ends. And a perfect normal distribution will be what we call symmetrical. So there'll be the same amount of people here as there are here, same amount of people here as there are here. So the line here is symmetrical. It's perfectly symmetrical. If you cut it in half at the highest point, the shape of the line will be the same. That's for a perfect normal distribution. For this class and for doing descriptive statistics, it's okay to say that it looks relatively normal because we're not going to have many curves that are perfectly normal in this class from the data. So if it looks kind of like a bell curve, it's okay to say it looks like a bell curve. It looks like a normal distribution. That's fine to say. And this is just another example of a bell curve. So there's IQ scores, and there's more people who are average. 100 is the average IQ. So that's the highest score. And then as you get higher on IQ, there's fewer people. And as you get lower on IQ, there's fewer people. And also in terms of the normal curve, it tends to be a little bit more bulkier in the middle. So there's more people close to the average, and there's far fewer people who are far away from the average, both in terms of being high above the average and also being low below the average. So that's a normal curve. So again, it's okay for our exercises in this class to say that it looks relatively normal or looks normal. We don't want to say that it has to be perfect like this. We've already talked about skew. So remember with skew, we talked about where does it go in terms of the distribution. So this is a perfect normal curve right here. This is kind of weird. This is what we call bimodal. What does bimodal mean? It means that it has two peaks. A mode is the most frequent. So we could get a variable that has two peaks. Let's say that I'm looking, if I'm probably not a very good professor, my distribution of test scores might look like this. There might be half the people doing fairly well in the class and then half the people failing. That's probably not a good thing. That would be a bimodal distribution. There's a group of people who are doing well. There's a group of people not doing well. Because it looks like there's two peaks, two mountains here. So that's bimodal. It's also calling it symmetrical, which means that if we slice this thing in half, half of the people are doing well, half of the people are not doing so well. Then there's skewed distributions. So this is a positive skew, so it kind of looks somewhat normal here, but then we have a tail. Remember, in terms of our sleep during the midterm, when people are having their midterm exams, we had a positive skew because we had more people getting less hours of sleep, and we had fewer people getting more hours of sleep. So that was a positive skew. So again, positive does not refer to it's good or bad. It's just referring to where is the tail. And the tail is where there's fewer people. So fewer people got less hours of, or fewer people got more hours of sleep. On the high end, it means that when you have a positive skew, what's happening is that your sample is scoring a little bit low. They're low on your variable because there's fewer people on the high end of the variable getting higher scores. Negative skew is just the opposite. Negative skew is when there's fewer people on the lower end of your scale. So let's say, I'm just going to use narcissism again. Let's say I have a sample. This would be kind of a scary sample. If I had a sample and this was my data on narcissism and it had a negative skew, I would say that the sample is relatively high on narcissism because there's more people over here. There's more people on the right. There's more people on the high end of the score of narcissism. And there's fewer people on the lower end of narcissism. So negative skew would mean that your sample's relatively high in the variable. In this case, it would be narcissism. This sample's relatively high on narcissism because there's a negative skew. There's fewer people with low scores on narcissism. So that's skew. The other thing that we want to talk about is kurtosis. So kurtosis is probably better understood when we look at, we'll do this later. We actually did the skew already. We did the skew for the first week and midterm. Remember, for the first week, it looked kind of normal. And then midterm, we had a positive skew because there were fewer people getting more hours of sleep. So there was a positive skew for midterm, and there was basically kind of a normal looking curve for first week. This is kurtosis. Kurtosis is basically where's the bulk of the data. They talk about the thickness of the tails, but I think that's a little bit harder to grasp. I think it really is about the bulk of the data. So mesokurtic just means in the middle. These are normal curves, by the way. They just differ under kurtosis. So this line right here, meso is in the middle. It's kind of what we are kind of used to. If I asked you to draw a normal curve, you would probably draw something like that. It looks normal in terms of there's more people in the middle, there's fewer people on the ends. But kurtosis can change while also being normal. So let's look at this other one, leptokurtic. If you see, if we go from the meso, it gets stretched up here, it gets higher, and if you want to imagine, if you have this thing, and just think about it like an object. If you're pulling an object up, what's going to happen to the ends of it? It's going to be smaller, right? So you're going to pull the top up. This thing is going to come up a little bit. It's going to look maybe a little bit smaller. And there's going to be more people here. So in a leptokurtic distribution, there's going to be more people here because you've drawn them up. Just imagine like there's people there in some sort of slime object that you can grab. So if you grab the middle of it and pull it up, you're pulling the people up, right? There's more people here. There's more people in the middle now, and there's fewer people on the ends because you pulled them up. So that's what leptokurtic is. Leptokurtic is more peaky. Peaky, it's higher, it's drawing people more in the middle, and there's fewer people on the ends. So leptokurtic. So one way that I tell my students to remember this is lepto is like you're leaping up. Think about leaping up. Let's look at the other one that's in red. So again, let's start with the meso, the middle. Let's pretend that this is an object and we can push it down. Let's push it down, the middle down. What happens when we're pushing the middle down? What happens? People get pushed out this way and they get pushed out this way, right? So the middle, close to the average is here in the middle of all of these curves. There's fewer people around the average because we pushed them out. So there's more people on the ends. There's more people who are higher, more people who are lower. Why is that? It's because we've pushed down in the middle and there's fewer people in the middle now. So one way that I tell my students to remember this is think about a platypus. What does a platypus look like? Platypuses are very close to the ground. They kind of look like this, right? They kind of have their tail and then they have a little bit of a butt or something here. And then they have their head here with the bill, the duck bill. So that's what that looks like. So Leptokurtic is you're pushing it down, there's fewer people in the middle. I'm going to look at the data. So this is how the peaky. With our sleep data, it's really hard to tell kurtosis because there's fewer people. So if we look at the sleep data, I'm going to run the first week. I think it looks a little bit better. Make sure the chart's there. It is. You know, we get a chart and we can look at it, but it looks a little weird to me because it looks like, oh my gosh, there's a big difference here, right? Well, not really. It's just 2 people. Actually, sorry about that. It's 3 people. So it's difference between 9 and 6. So 3 people, it looks like a big difference. Why is that? Because our sample size is pretty low. Our sample size is 40. And so trying to judge kurtosis, and even normal curve and skew is a little bit difficult, but definitely kurtosis is very difficult to do when we have a small sample size. And I want to make sure I don't close all my data. I'm going to open up a larger sample of data. It's easier to see, especially normal curves, skewed curves, and definitely kurtosis with a bigger sample set. So we're going to look at a bigger sample size. And we're going to look at a representative sample of American women that was collected a couple decades ago, I think, by the University of Michigan. So let's open up American women. And I don't know if I can do this. I can do it. It'll take a long time. You can see there's a lot of rows here, right? In fact, there are 5,500, whoops, 5,500 women in this sample. And hopefully that hasn't changed things too much. So we can actually run the frequency distributions. And so let's just look at hours of sleep. We've been talking about hours of sleep. So we actually have a variable here from this sample of over 5,000 women, how many hours of sleep they get on average. And let's do a chart, because we'll see that when we have a table, it looks really messy. And so this is a great example that tables are really useful when you have a small amount of possible variable answers with a small amount of people. And actually you see here is that for this sample, they let people say 3.5, 3.8, etc. So it's really, really long. So this table is almost useless because it's really hard to tell what the distribution's like from the table when we have a large sample like this and we have a lot of different answers. So what we want to do is we want to go to the histogram, which is way down here, because the table is really long. Oh boy. There we go. I'm going to snip this to make it bigger. And here we go. So it's the same type of deal as the other histograms. You can see that the range is, similar. There's a sort of a range from maybe 3.5 hours of sleep to 10-ish here. So remember that this is just less hours, more hours on the horizontal axis. Frequency is, again, the number of people who said the different hours of sleep. And so one of the things that you might notice with the larger sample size here, and here the sample size is 5,566 people, it's less jaggedy. If you remember our smaller sample sizes, it was jaggedy. So 3 people, a difference between 9 and 6, there was a big difference in the lines. So it makes it more jaggedy. So in this case, with a larger sample size, it's going to be less jaggedy. So it looks a lot more normal. So the larger our sample size, typically it will look more normal. Is there a skew here? I think there kind of is. I think there's kind of a skew here. It's a very slight skew, but there might be a slight positive skew in this sample. If you kind of compare these little bars with these little bars for the same distance from the mean, it looks like there's a positive skew. So there's a bit of a positive skew. So there's fewer people getting more hours of sleep here. So again, with a larger sample size, we tend to have something that looks a little bit more of a normal curve. But we can still see that there's a little bit of a skew here. Is there a kurtosis? I don't think so. To me, it doesn't look, if it was leptokurtic, it would kind of look like this. There'd be fewer people in the middle. And so if it was leptokurtic, it would kind of look like this. If it was platykurtic, it would kind of look like this. It'd look kind of flat, and there's fewer people in the middle. And that would be platykurtic. So to me, this was probably mesokurtic. It kind of looks like what we would kind of typically see. So to me, it looks like it's mesokurtic. So leptokurtic would look more peaky. Platykurtic would look more flat. Okay, let's see where we are in the lecture. And we're almost done actually here. So this slide is just basically talking about misuses of graphs. So remember when we were sort of talking about if you have a small sample size, the bars can look really different, even though there's only a difference of 3 people. So a bar graph, maybe with a small sample size, you might want to think twice about doing it because it could make things look really weird. And here we have a number of homicides. So here's a misuse here in terms of, look, they have 42, 44, 46, 48, 50. So just a difference of 2 homicides looks like there's a huge difference. So over 2005, 2006, 2007, 2008, it looks like if you look at this graph, you think, oh my gosh, there's a lot more murders now than there used to be in the past. But over those 4 years, the increase has only been from 42 to 49, so only 7 more. It's probably not much of a difference. So it's probably more fair to display the data like this. There is an increase, but the increase is very slight. So we have to be very careful about graphing. We don't want our graphs, when somebody looks at like, oh my gosh, look at this, it's changed. No, it really hasn't. It's not much of a change. It's a slight change. So how we label our lines here is very important in graphs. Okay, we're towards the end of the lecture. So what shape is this distribution? Hopefully you didn't say symmetrical because it's not. Symmetrical means if we cut it in half, the shape over here is the same as the shape over here. Discrete, that doesn't even apply to the shape. So it's either negatively skewed or positively skewed. So what did you say in terms of skew? Remember, skew has to do with where the tail is. The tail is on the upper end of the variable, upper values. So this is a positive skew. The tail is on the upper end of the values. And remember that a positive skew means that there's fewer people on the higher end of your distribution. So if this was, let's say, narcissism again, if I plotted the frequency distribution for narcissism for my sample, and I had a positive skew like this, I would say that my sample is relatively low on narcissism. There's fewer people on the high end of narcissism, and there's more people on the lower end. So in general, my sample is low on narcissism if it has a positive skew. There it says positive skew. So there is a lab for this lecture. So I went a little bit slow through this lecture since it's the first lecture. And I probably will go slow for most of them because you can always speed things up. So hopefully that was relatively easy and a little bit more hands-on and a little bit more common sense. So there is a lab to do. There is no homework for this topic, but there is a lab, and that lab will be posted on Canvas. Let me know if you have any questions about this lecture. So take care.